Let's take a look at factor trees. What are they? What are they used for? And how can we make one? A factor tree is going to tell you what the factors are of an integer. So let's start with a small number like 10. If you wanted to know what the factors of 10 are, how could you do it? Well, you might say, to start with, that the number 1 is a factor of 10. And that would be true, because the number 1 is a factor of every positive integer. But if you're trying to break down a number, say you're working on a math problem and you need to break an integer down into its factors, then the number 1 actually isn't going to be that helpful, because 1 doesn't break a number down, right? 1 times 10, the 10 is still a 10. So a factor tree is going to help you break down a positive integer into its factors. So when we're doing a factor tree, keep that in mind. We do not want to say, a factor of 10 is 1 in 10. Because technically that's true, but that's not actually going to help us that much. Okay, so what number should we start with? What factor other than 1, bigger than 1, should we start with? So here's what to do. When we're doing a factor tree, you look, is the number an even number? In this case, 10 is an even number. If it's an even number, we're going to start with the number 2 on the left side like this. You just draw branches. That's why it's called a tree, because every number, at least at the top when we start, it's going to branch off into 2 branches. So 10 is an even number. We have the number 2. And then, to find what goes on the right side, you just divide 10 divided by 2. So 10 divided by 2 is 5. So here is a very small factor tree for 10. So if you wanted to then list what are all the factors of 10, well, you could start with 1, right? 1 times 10. Those would be factors. But then you can also have a 2 and a 5. So the factor tree tells you what are the factors of a number other than just 1 in 10. And we stop whenever we come to prime numbers. So 2 and 5 are prime. We cannot break these down even more, so we are done with the factor tree for 10. This is it. And here are the factors. Let's go to a bigger number than 10. That's just the small number we started with. So let's say 50 this time. Here we go. Now, same thing. To start with, I'm going to have a 2 on the left side because 50 is an even number. So let's do 50 divided by 2. 25. And now we want to break down 25. So we started with 50, we broke it down. The 2 is prime, so we're done with that one. Let's look at 25. 25 is not an even number. 25 is odd. So we cannot break 25 down with a 2. So we don't want to try 1, because 1 in 25 would not be that helpful. We cannot do a 2 because this is odd. So then we just go up 1 by 1. 1 does not work. 2 does not work. What about 3? 25 divided by 3, would that be a whole number? No. So 3 would not work. We go up one more, 4. Can we do 25 divided by 4? No, that would have a decimal or a remainder. So let's go up to 5. Can we divide 25 by 5 and get a whole number as its quotient? Yes, we can. So let's try 5. 25 divided by 5 is 5. And since 5 is a prime number, we are done with our factor tree. So once again, If we wanted to list the factors of 50, we could say 1 and 50. We could say 2 and 25. 2 and 25. And then 5. And you can see, if we compare 10 versus 50, what a big difference the factor tree is. We have another layer added, right? This is just one layer under. This is 2 layers. And then our list, it can grow a little bit more here into, instead of 4 pieces or 4 numbers, we have 5. Now let's go to an even bigger number, right? So let's say, what if we have, I'm going to try a bigger number here. Let's say 210. Let's do the factor tree for 210. All right, once again, I'm going to start with 2 because this is an even number. 210 divided by 2 is 105. So let's break the 105 down. 1 would not be useful. Don't do 1. 2 will not work because this is an odd number. What about 3? Well, 3 would work because a trick is if you sum up the digits, 1 plus 0 plus 5 is 6. 6 is divisible by 3, so the whole number is divisible by 3. So let's try this. 105 divided by 3. That would be 10 divided by 3 is 3. And I carry the 1 over. 15 divided by 3 is 5. So we've got 35. Let's break the 35 down. 1 would not be useful. 2 would not work. 3 would not work. 4 would not work. 5 would work. 5 and 7. So now, if we wanted to know the factors of 210, we could say 1, 210, right? 1 and 210, 2 and 105, 105, 3 and 35, 3 and 35, and 5 and 7. Boom. So hopefully with these 3 example numbers, you can start to see the pattern of increasing factors for increasing numbers. But you can also see that the procedures are really the same. I could go to bigger number and bigger number, and all we would need to do is add another layer to our factor tree. But this is why they're useful. They break down any number. We can go from small numbers like 10 to big numbers like 210 to even bigger ones. We could break down any positive integer into its factors, and we can see all of the factors listed in an organized way from small to big in corresponding pairs like this.